Hello classmates. Welcome to Learn Air Pollution Control Technology. In this section, we will learn 2.3, Calculation of Volume of Smoke and Pollutant Emissions. Excess air coefficient alpha equal to the ratio of actual air volume to theoretical air volume. Excessive air excess coefficient indicates too much excess air will increase the amount of smoke, to increase the power consumption of the induced draft fan, and reducing the temperature of the combustion chamber, unfavorable to combustion. Excessive air coefficient is too small, will cause incomplete and incomplete fuel combustion, increase in fuel consumption. Usually, the excess air coefficient is greater than 1. In actual combustion engineering, on the premise of ensuring complete combustion, minimize air excess coefficient as much as possible. Theoretical flue gas volume refers to the given theoretical air volume alpha, under the condition of equal to 1, the amount of smoke generated by complete combustion of fuel. Theoretical flue gas volume equal to the amount of combustion products generated by complete combustion of fuel. Add the amount of water and nitrogen brought in by air and fuel. Now, please take a look at the example questions. The flue gas temperature of a certain boiler is known to be 150 degrees Celsius. Pressure is 98 kilopascals, 87% carbon in heavy oil used, hydrogen 12%, sulfur 1%. Calculate the combustion of 1 kilogram of heavy oil, the theoretical amount of smoke generated. Firstly, the first step. Calculate the theoretical oxygen demand required for fuel combustion. Among them, combustible components include carbon, hydrogen, and sulfur. The theoretical oxygen demand they ultimately need is 102.8. The amount of product generated is 132.8. The second step is to calculate the amount of nitrogen brought into the air. 102.8 times 0.79 and divided by 0.21. This is the proportion of nitrogen in our air, ratio to oxygen. Finally, 386.7 moles was obtained. 3 ideographic comma calculate the theoretical flue gas volume under standard state. 386.7 plus 132.8 multiplied by 22.4, multiplying it by 10 to the power of minus 3 equals 11.64 cubic meters. 4 ideographic comma according to the ideal gas state equation, PV equals nRT, the theory of standard states. Conversion of flue gas volume to actual flue gas volume under operating conditions, equal to the sum of the theoretical flue gas volume and the excess air volume. Please complete the following exercise questions after class. Known heavy oil elements. The analysis result is 85.5% carbon element, hydrogen element 11.3%, oxygen element 2%, nitrogen element 0.2%, sulfur element 1%. Calculate when the excess coefficient of air is 1.1, the actual amount of air required under the label box, and the amount of smoke generated. Okay. Section 2.3, Smoke volume and pollutant emissions. That's all we need to talk about. Thank you all.